Hey everyone! What if I told you that instead of colonizing Mars, humanity's next big frontier could be Venus? Yeah, Venus! The planet known for its scorching temperatures and crushing atmospheric pressure. Sounds crazy? Let's dive into why it might not be as far-fetched as it seems. First, let's talk about where we're not going on Venus. The surface of Venus is a nightmare. It's hot enough to melt lead with temperatures around 900 degrees Fahrenheit. The atmospheric pressure is about 92 times that of Earth's at sea level, and the clouds are made of sulfuric acid. So, surface colonization? Not happening. But here's where things get interesting. About 30 miles up in Venus's atmosphere, conditions become much more Earth-like. The pressure and temperature drop to levels where humans could actually survive. Imagine floating cities suspended in the sky, riding on the planet's thick cloud layer. In this habitable zone, temperatures range from 86 to 158 degrees Fahrenheit, still hot, but manageable with the right technology. One of the biggest advantages of Venus is its proximity to Earth. It's only about 38 million kilometers away at its closest approach, making travel and communication significantly easier compared to Mars. Plus, Venus has almost the same gravity as Earth, which is crucial for long-term human health. So how would we go about creating these floating cities? Picture massive airships filled with breathable air, which is lighter than the surrounding CO2-rich atmosphere. These floating habitats would be safe havens, complete with greenhouses for growing food, labs for scientific research, and living quarters for astronauts. Now, let's talk energy. Venus is closer to the sun, receiving about twice the solar energy that Earth does. This abundance of sunlight could be harnessed to power our floating cities with solar panels. Plus, the thick atmosphere offers opportunities for wind energy. But it's not all sunshine and roses. The thick cloud cover would make solar power generation tricky. There's also the challenge of the acidic atmosphere, which would require resilient materials and technology to withstand corrosion. Despite these challenges, the dream of colonizing Venus opens up fascinating possibilities. It pushes us to innovate, to adapt, and to think outside the box. So, while Mars might be the poster child for space colonization, let's not rule out Venus just yet. Thanks for watching. If you enjoyed this thought experiment, hit the like button and subscribe for more mind-blowing content. Until next time, keep looking up. Welcome back. In this chapter we'll delve into the technical and logistical challenges of building and maintaining floating cities on Venus. From the harsh acidic atmosphere to the need for resilient materials, we'll explore the obstacles that must be overcome. We'll also discuss potential solutions and innovations that could make Venus colonization a reality. First, let's talk about the acidic atmosphere. The clouds of Venus are filled with sulfuric acid, which can corrode most materials we're familiar with. Creating habitats that can withstand this acidic environment requires the development of advanced acid-resistant materials. Think of specialized coatings or composite materials that can endure long-term exposure without deteriorating. Next, there's the issue of maintaining a stable altitude for our floating cities. The atmosphere of Venus is dynamic, with strong winds that can reach speeds of up to 224 miles per hour. To keep our floating habitats stable, we would need sophisticated anchoring systems and advanced navigation technology. These systems would ensure that our cities remain at the optimal altitude, where the conditions are most Earth-like. Energy generation is another critical challenge. While Venus receives abundant sunlight, the thick cloud cover poses a significant hurdle for solar power. One potential solution is to use a combination of solar panels and wind turbines. High-altitude wind turbines could harness the powerful winds of Venus, providing a reliable energy source even when sunlight is scarce. Water, a vital resource for any colony, is not readily available on Venus. However, we could extract water from the planet's atmosphere by using advanced filtration systems. These systems would collect water vapor, purify it, and store it for use in our floating cities. Communication and transportation also present unique challenges. The dense atmosphere of Venus can interfere with radio signals, making communication with Earth difficult. To address this, we could deploy a network of relay satellites in orbit around Venus, ensuring a stable communication link. For transportation, specialized airships or spacecraft would be needed to travel between the floating cities and Earth. Finally, let's not forget the psychological and social aspects of living in a floating city. The isolation and confinement could take a toll on mental health. To combat this, our habitats would need to include communal spaces, recreational facilities, and virtual reality systems to simulate Earth-like environments. In conclusion, while the challenges of colonizing Venus are formidable, they are not insurmountable. With the right innovations and technologies, we could turn these floating cities from science fiction into reality. Thanks for joining us on this journey through the possibilities of Venus colonization. If you found this video intriguing, don't forget to like and subscribe for more exciting content. Until next time, keep dreaming big. Welcome back. In this chapter, we'll highlight the benefits of establishing a human presence on Venus. We'll compare these benefits to those of colonizing Mars, and discuss why Venus might be a more attractive option. Firstly, let's consider the scientific benefits. Venus, often called Earth's sister planet, offers unique opportunities for studying planetary evolution. Understanding Venus's runaway greenhouse effect can provide crucial insights into climate change and atmospheric science. Economically, Venus's thick atmosphere could be a rich source of industrial gases and chemicals. The potential for solar energy harvesting is immense, given Venus's proximity to the Sun. Floating solar farms could generate vast amounts of energy for Earth or floating cities. Strategically, Venus's closer proximity to Earth is a significant advantage. The shorter travel time reduces mission costs and risks, making Venus a feasible option for early colonization. Venus's dense atmosphere provides a natural shield against space radiation, offering better protection for settlers. While Mars has its own advantages, such as water ice, it also poses significant challenges. Mars's thin atmosphere and lower gravity make it difficult to create a stable environment for human habitation. In contrast, Venus's upper atmosphere offers Earth-like conditions, making it more hospitable for long-term settlement. In conclusion, Venus's scientific, economic, and strategic benefits make it a compelling option for colonization. By overcoming Venus's unique challenges, we could unlock new frontiers of knowledge and innovation. Thanks for joining us on this exploration of the benefits of colonizing Venus. If you found this discussion thought-provoking, don't forget to like and subscribe for more fascinating content. Until next time, keep reaching for the stars. Welcome back. In this chapter, we'll speculate on the long-term future of human space colonization. We'll discuss potential missions to other planets and moons, and the role of international cooperation and private industry in making space colonization a reality. We'll also consider the ethical and philosophical implications of becoming a multiplanetary species. As we look beyond Venus and Mars, the possibilities for human expansion in our solar system are vast. Moons like Europa, Titan, and Enceladus, with their subsurface oceans, offer intriguing destinations for future exploration. These icy worlds could harbor the conditions necessary for life, making them prime candidates for scientific missions and potential colonization. International cooperation will be crucial in these endeavors. Space agencies like NASA, ESA, Roscosmos, and CNSA have already demonstrated the power of collaboration through projects like the International Space Station. By pooling resources, expertise, and technology, we can overcome the immense challenges of space colonization. Global partnerships will be essential for sustainable and peaceful exploration of space. Private industry also plays a vital role in this new era of space exploration. Companies like SpaceX, Blue Origin, and others are pushing the boundaries of what's possible with innovative technologies and ambitious missions. Their efforts to reduce the cost of space travel and develop reusable rockets are making space more accessible than ever before. The synergy between public agencies and private enterprises could accelerate our progress towards becoming a multiplanetary species. However, as we venture into space, we must also consider the ethical and philosophical implications of colonization. What responsibilities do we have to protect these new worlds? How do we ensure that space exploration benefits all of humanity, not just a privileged few? These questions are critical as we navigate the future of space colonization. Becoming a multiplanetary species could redefine our understanding of life and our place in the universe. It challenges us to think beyond our planetary boundaries and consider the long-term survival and evolution of humanity. The prospect of living on other worlds invites us to imagine new ways of life, governance, and community. In conclusion, the future of human space colonization is filled with exciting possibilities and profound challenges. By embracing international cooperation, leveraging private industry, and addressing ethical considerations, we can pave the way for a sustainable and inclusive future in space. Thank you for joining us on this speculative journey into the future of space colonization. If you enjoyed this discussion, don't forget to like and subscribe for more thought-provoking content. Until next time, keep